Let's take a look at this example. Before we are going to simplify this expression, we are going to prepare again Karnaugh map just to make sure that you know how to do it. You have to always look at the first variable. First variable represents always the most significant bit. A represents most significant bit and D represents the least significant bit. A is the most significant bit and D represents the least significant bit. So that's why I'm going to write over here A, B, and CD over here. So again I have CD, 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 and I have AB, 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 AB. Remember that the variable which is above 0 is supposed to have negation bar above itself. I'm going to have A naught, B naught, C naught, D naught, C naught, D naught. My Karnaugh map is ready for the simplification, but just take a look at this expression. This expression is not standard SOP. Why is not standard? Because this term is missing one variable, B. This term is also missing one variable, B. This one is missing D. This one is missing D. This one is standard because it has 4 variables. And this one is missing 2 variables. First, what we are going to do, we are going to expand these not standard terms to the standard SOP term for this expression. So it means that I have to find the missing B over here. This time I'm going to show you how to expand the terms using the numbers. Now I have A naught, C naught, D naught. I'm missing B. I'm going to write small b. Keep in mind that for SOP, the variable without the negation bar represents 1 and the variable with negation bar represents 0. So I'm going to say A naught is 0, C naught is also 0, and D naught is also 0. B, variable B can be 0 or 1. That's why first I'm going to assume that B is 0. Next, I'm going to assume that B is equal 1. And keep in mind that these 3 variables are going to stay the same. All of them are zeros again, because all of them have bars above themselves. This is binary 0 and this is binary 4. It means that this term represents 2 ones, 1 in the cell 0 and 1 in cell 4, because I have binary 0 and binary 4. I'm finished with this term. Let's take a look at this one. I have A, C naught, D naught. Again, I'm missing B. If I'm missing just one variable, means I'm going to have just 2 numbers, because one variable can represent just 2 combinations. Okay? Now, so I have A is 1 in this case, because it has no negation bar, and I have C naught, which is 0, and I have D naught, which is 0. And I have 1, 0, 0. Remember, one variable can have 2 combinations only, can carry 2 combinations, 0 or 1. That's why I'm going to first assume that B is going to be 0, and for this one, B is equal 1. This is binary 8, and this is binary 12. That's why this term represents 2 ones in cell 8 and cell 12. I'm finished with this one. Let's take a look at this one. I have A naught, B naught, C naught. I have A naught, B naught, C naught. I'm missing D. We said that one variable can carry 2 combinations, 0 or 1. Anytime I have bar, negation bar, above the variable, that variable represents 0. That's why I'm going to have 0, 0, 0. And also I'm going to write 0, 0, 0. These zeros are never going to change for this term, because A naught, B naught, C naught are not going to change. D, I don't know if this 0 or 1. That's why I'm going to write this could be 0 or could be 1. This is binary 0. We marked already 0. That's why I'm not going to write another one inside of this cell. And this is binary 1. That's why I'm going to write 1 in cell number 1. I'm finished with the third one. Now let's take a look at the fourth term. I have A, B, C naught. Again, I'm missing D. Keep in mind, one variable can carry 2 combinations, 0 or 1. A represents 1 because there is no negation bar. B represents also 1 because there is no negation bar. C naught represents 0. Again, I'm going to have 1, 1, 0. This is binary 12. We marked already binary 12. That's why I'm going to just go to another binary number. I have 1, 1, 0, 1. This is binary 13. That's why I'm going to write 1 in cell number 13. I'm finished with this one. Okay, let's take a look at this one. I have A naught, B, C, D. This term has 4 variables already. This is standard form. That's why I'm going to go straight to that particular cell. Keep in mind, this is 0, 1, 1, 1. This is binary 7. That's why I'm going to write 1 in cell number 7. This is also standard form because it has 4 variables. And I have 1, 0, 1, 1. This is binary 11. That's why I'm going to write 1 in cell number 11. I have C, D naught. This is not standard form. That's why I'm going to find in what cells I'm supposed to write ones. I have C, D naught. I'm missing A and I'm missing B. One variable can carry 2 combinations, 0 and 1. When I'm missing 2 variables are going to carry 4 combinations. That's why I'm going to write over here 1, 0, 1, 0, 1, 0, 1, 0, because D naught is going to represent always 0, C is going to represent always 1, and I have to write the 4 different combinations for AB. The first one is 0, 0. Next one is 0, 1. Next one is 1, 0. And I have 1, 1. This is binary 2. Binary 2 is over here. Next one is binary 6. Next one is binary 10. And the last one is binary 14. I mapped all these terms. Next, I'm supposed to simplify this expression if this is possible. Let's take a look how many groups we can create in this map. So, keep in mind that we're supposed to always create the biggest group if this is possible. I have 4 ones in this column and I have 4 ones in this column. Keep in mind that we can fold Karnaugh map and we can make these 2 columns next to each other. That's why I'm going to create one group like this. Group of 8 ones. This is one group. Next, I have group of 2 over here. I have group of 2 over here. And I have group of 2 and group of 2. Let me start from the biggest group. This group is placed in 4 rows and 2 columns. Remember, we said anytime we have 4 variable Karnaugh map and group is placed in 4 rows or 4 columns, means on the side, in this case, of these 4 rows, there is no common variable for let's say, row 1, 2, 3, and 4. Okay, there is no common variable. That's why I'm going to ignore completely whatever is on the side of these 4 rows. The common variable for these 2 columns is D naught. D naught, D naught. C naught and C are complements. We said that we're going to ignore complements. That's why I'm going to copy down only D naught. So I have D naught. I'm finished with this big group. Let's take a look at this group. This group is placed in 1 row and 2 columns. Anytime I have group placed in 1 row, I simply copy down everything, whatever is at the side of this row. So I have A naught, B naught. The common variable for these 2 columns is C naught. That's why I'm going to write C naught. I'm finished with this group. This group is placed in 1 row and 2 columns. At the side of this row I have A naught, B, and at the top of these 2 columns I have C. I'm finished with this one. Let's take a look at this one. The variables at the left side of the row we have A, B, and the common variable at the top of these 2 columns is C naught. I'm finished with this one. And I have another one. This group is placed in 1 row again. I copy down A, B naught, and at the top I have C. Next, you're supposed to check if you can factorize anything from this expression. Remember, after Karnaugh map, you cannot use Boolean algebra. You can use De Morgan's theorem, you can do some factorization, you can use XOR or XNOR gates, but you cannot use Boolean algebra anymore. Please notice that we can factorize A naught from these 2 terms, and I can factorize A from these 2. Let's take a look what I'm going to have. I'm going to have D naught, I have to copy down D naught, or A naught, and I have B naught, C naught, or BC. Or I have A, and this is B, C naught, or B naught, C. Please notice that this is exclusive NOR. This is exclusive OR. That's why I'm going to have D naught or A not, and I have B exclusive nor C, or A and I have B exclusive or C. Let's continue. This time we are going to call exclusive nor Q not, and exclusive or I'm going to call Q. And let me rewrite this one more time. I have D not or A not, Q not, or A Q. Again, this is nothing else, just the exclusive NOR. That's why I'm going to write this. D not or A exclusive NOR with Q. This is D not or A exclusive NOR, and Q is B exclusive or C. B exclusive or C. This is my simplest Boolean expression. Next, I'm supposed to implement it. I have D not. This is my D. And I have A. And I have exclusive OR with inputs B, C, and I have exclusive NOR gate because A is exclusively NOR with exclusive OR, and everything has to be ORed together. These are the solutions to my problem.